So y'all, 4.1 is this idea of these things called probability distributions, okay? And we're going to talk about something called a random variable. So a random variable, y'all, an outcome is like rolling a die, a counter or measure. So that's what we're going to talk about for our random variable. It's not, guys, 4.1 is going to be pretty easy breezy cover girl. At least I hope it will be. So a random variable X represents a numerical value associated with each outcome of a probability experiment. A random variable, y'all, is discrete if it has a finite or a countable number of possible outcomes that can be listed. And a random variable is continuous when it has an uncountable number of possible outcomes, represented by an interval on a number line. So, y'all, we want to know if the random variable is going to be discrete or continuous. So again, discrete, let me just kind of give you some feedback here. Discrete is when it has a finite or a countable number of outcomes that can be listed. So the first one says, let X represent the number of books in the library. So if we walked over to the library, we could sit there, right? And we could just go, bless you, we could go each aisle at a time and start counting 1, 2, right? At some point we would end, right? But we can count it. It's finite. There's going to be a time when we're going to end, right? So this here, y'all, would be what we call discrete, okay? Now, let X represent the distance a baseball travels after being hit. So, y'all, if we were to go to a game, right, and we're going to count how many times, what's the distance? Y'all, the distance that a ball is hit, there's an infinite number of values that it can hit, right? So it can go 10 feet, it can go 10.1 feet, it can go 10.11 feet, it can go 10.8 feet. There's no ending to how far the ball is going to end. So this here, y'all, would be what we call continuous, okay? So when we have either discrete or continuous random variables, knowing which one it is going to be important to figure out the techniques that we're going to be using. So y'all, we're going to talk about discrete probability distributions. So a discrete probability distribution lists each possible value the random variable can assume together with its probability, and it has to satisfy the following conditions. The first condition, y'all, is that the probability of each event has to be a number between 0 and 1, okay? And then the other thing is, if we were to add up all the probabilities, y'all, all the probabilities should add up to 1. Y'all, when we were here last week and we started talking a little bit about probabilities, and I said the easiest probability for us to think about is if we went home this afternoon and Tim Smith said, hey, there's a 65% chance it was going to rain. Do y'all remember what the percent chance if it not raining was? If it was 65 that it was going to rain, what's the percent that it's not? 35, right? Guys, the percent that it does rain, 65, plus the rent that it doesn't rain, 35, if you add them together, that's 100% or the same thing as 1, right? Those are my only possibilities. Either it rains or it doesn't, okay? When we're making a discrete probability distribution, we're going to let X be our discrete random variable, and we're going to list all the different outcomes. I'll walk you through the process in a minute, y'all. We're going to make a frequency distribution for our possible outcomes. We're going to find the sum of the frequencies. We're going to find the probability of each possible outcome by dividing the frequency by the sum of the frequencies. And we're going to make sure that each probability is between 0 and 1 and that they add up to 1. So let me give you an example. Okay, the first part here, y'all, for the first part, it says, determine the required value of the missing probability to make the distribution a discrete probability distribution. So, y'all, a couple of things here. They gave us some values, 3, 4, 5, and 6, whatever that happens to be. The probability that we get a 3, a 4, a 5, or 6. Those are my only options. I can only get a 3, 4, 5, or 6. And these are the probabilities. So, y'all, first thing we want to make sure is that when we add up all those probabilities, y'all, that they add up to the number 1, okay? So what I need to figure out is what number would we have to put in that red box right there so that when we add them all up, we get 1. So y'all, first thing I'm going to do, I'm going to take my calculator. I'm going to say, what's 0.21 plus 0.43 plus 0.12. Okay, that adds up to 0.76. But the whole thing has to add up to 1. So if I wanted to figure out what is this value going to be, y'all, I can just say, well, what's 1 minus 0.76? And this number here, y'all, has to be a 0.24, because now when we add them all up, we get to 1. Okay. Okay. So for the first part, that's all we're trying to do. Let's just keep it simple. Let's try the second part. Determine whether the distribution is a discrete probability distribution. Okay, so y'all, first thing I need to do, all of the numbers here have to be numbers between 0 and 1. They look like they are, okay? They're smaller than, they're 0, but they're never bigger than 1. Second thing is, I need to make sure that if we were to add up all those numbers, y'all, they add up to the number 1. So let's do this. So I'm going to take my calculator right here, and I'm going to say 0.10 plus 0.20 plus 0.30 plus 0.20 again plus 0.1. It adds up to 0.9. Guys, not a probability distribution. Because it didn't add up to 1, right? It added up to 0.9. It has to add up to 1, okay? Let's take a look at the next one over here, y'all. All of those numbers there have to be between 0 and 1. That probability right there, y'all, negative. Not a probability distribution, okay? Not a probability distribution because we have that guy right there that's negative, okay? All the numbers should be between 0 and 1. And they should, when you add them all together, they should add up to 1. Okay, let's try the last one. Oops, sorry. Let's try the last one. And let's see if that is a probability distribution. So 0.09 plus 0.21 plus 0.40 plus 0.21 plus 0.09. Boom, they add up to 1. Every number in my list is a number between 0 and 1. And we're going to say, yes, this is a probability distribution, right? Because all the numbers are between 0 and 1, and the whole thing adds up to 1, okay? All right. So, y'all, let's see if we can figure out how to make a probability distribution just from some information, and then we'll answer some questions based on that, okay? Let's take a look here, y'all. It says a company tracks the number of sales new employees make each day during a 100-day probationary period. The results for one employee are shown. Construct and graph a probability distribution. Okay, so y'all, first thing I need to figure out is I'm going to have to find my probabilities. So I need to first find how many days are we looking at here, y'all. So one thing we can do, we can add up all the days here. But y'all, I want you to notice something. In this problem, they told me it was already for how many days? 100 days. So if we were to add all of them up, y'all, it would be 100, okay? Now, y'all, what I'm going to do right here is in my first row going across, I'm just going to write those numbers. 0, 1, 2, 3, 4, 5, 6, and 7. Now, we're going to find our probabilities. So, y'all, 16, this is the number of the new sales each employee made. Okay, so let me take a look and let me see if I can figure out what this information means here. 0 for my number X. Y'all, that means that this person did not make a sale at all. Out of the 100 days that they worked, how many days did they not make a sale at all? 0.16, okay? So y'all, what I want to do now is I want to figure out what's 16, and let me divide that number by 100. It's just 0.16. Yeah, I made it 100, so it'd be real easy to do. All these are going to be point whatever the number is, okay? Now, there were a certain number of days, where this person made one sale. How many days did they only make one sale? 19. So what's the probability there, y'all? 0.19, right? Okay, let's continue to fill out that little chart. So everybody agree this is going to be 0.15, 0.21. Y'all, for the next one, what would you write? 0.09, very good. 0.10, 0.08, and 0.02. Okay, so y'all, let's see, man, where did that come from? Sorry. Okay, guys, I'm sorry I copied and pasted the wrong part here. Let's do it like this. Let's say, well, I guess they're selling cars. Okay, let's just say they're selling cars. Okay, find the probability that 5 or 6 cars were sold. Okay, so they're selling cars here. Okay, so y'all, the probability of 5 or 6 cars were sold, we're going to take the probability for 5 and we're going to add the probability for 6. So the probability for 5, y'all, would be 0.10. The probability for 6 would be 0.08. And if we add those together, y'all, that's going to be 0.18. Okay. Find the probability that 4 or more cars were sold. Y'all, what numbers do you think I would add here to do 4 or more cars? What numbers do y'all think we would add? So let's think about it this way. These are the number of cars, right? They sold no cars, 1 car, 2 cars, so on and so forth. 4 or more cars. What numbers do you think I would look at? Y'all agree those right there, right? So look, we're going to take 0.09 plus 0.10 plus 0.08 plus 0.02, and let's add those folks together. 0.09 plus 0.10 plus 0.08 plus 0.02. And y'all, I'm coming up with 0.29. Okay. Okay. Now let's take a look at the next one. Find the probability that the number of cars sold was between 3 and 5 inclusive. Inclusive, y'all, means we're going to include those numbers. So we're going to just look at those folks right there. Okay. So y'all, I'm going to write those out. I'm going to put 0.21 plus 0.09 plus 0.10. Yeah, because it's between 3 and 5 inclusive, right? So that means that they sold either 3 cars or 4 cars or 5 cars, right? Y'all, look at the last question. The last question here says, find the probability that at most 3 cars were sold. Yo, what do you think the phrase at most means? Do you think at most means 3 or more? Or do you think at most means 3 or less? 3 or less, right? At most means no more than 3. So no more than 3, y'all. So if we're looking at no more than 3, we're going to look at all of those, right? No more than 3, which means they sold either 3, 2, 1, or they didn't sell any cars, okay? So we're going to add all of those folks together. 0.16 plus 0.19, 15, and 21. Okay. So 0.16 plus 0.19 plus 0.15 plus 0.21, boom, 0.71. There we go. Y'all, let me ask you a question. Before I go on to anything else, did it make sense how we were able to find those numbers here? And I know that we just said, look, we're really just writing 0.16, but why did we write 0.16? Because we were taking 16 and we were dividing it by 100, and because it's 100, it makes it really easy to do, right? But my next question is, once we had this chart right here, wasn't it easy to find those questions because we could just look at the little boxes and add and figure out which ones we needed to use? That makes sense? Okay. So y'all, we're going to find something that we call the mean, the variance, and the standard deviation of a probability distribution. Okay. So, y'all, first thing I'm going to do here, I'm going to copy what we had in the first table. I'm going to copy it down over here. Okay. So look, right here, I'm going to write 0, 1, 2, 3, 4, 5, 6, 7. And then I'm going to copy my numbers again. 0.16, 19, and 15. 0.16, 0.19, 0.15. Let's see. 21, 0, 9, and 10. 0.29. Is that right? 21, sorry. 21, 0, 9, and 10. And then what are the last two? 0, 8, 0, 2. Okay. Y'all, if we were to add all those numbers up together, boom, we'd get 1. Okay. Because it's 100%. All those decimals added up would give us 1. Y'all, what I want us to do now is we're going to find the average. Okay. We're going to find the average here. The way we're going to find the average, y'all, is we're going to multiply these numbers straight across. Okay. So 0.0 or 0 times 0.16 should be 0. 1 times 0.19, 0.19. 2 times 0.15, I know is 0.30. 3 times 0.21, let's see, 3 times 1 is 3. 3 times 2, 6. Okay. 4 times 0.09 should be something like 0.36. Okay. 5 times 0.10, 0.50, right? You can use your calculator for this too, y'all. I'm just multiplying. 6 times 0.08, 0.48. 7 times 0.02, 0.14. Now, what we're going to do, y'all, we're going to find the average. The way we're going to find the average, y'all, we're going to add up all those numbers together. So let me clear this out. 0 plus 0.19 plus 0.30 plus 0.63 plus 0.36 plus 0.50 plus 0.48 plus 0.14. Okay, 2.6. All right. Interpret the results. Okay, so we got 2.6. Y'all remember, this person was selling cars. Okay, they were selling cars. In those 100 days, on average, what we would say is each day, they sold between 2 and 3 cars. That's all we're saying. On average, if you were to take all 100 days and figure out how many cars did they sell, on average, they sold between 2 and 3 cars. They sold 2.6 cars. But we would say, I mean, you can't sell 0.6 of a car. So we're going to call it between 2 and 3 cars, right? That's how we basically do the average. Okay. Now, y'all, when we were first talking about variance and standard deviation, I said, look, we could find, what does that mean? 2.6. Let's take the difference, right, of each number and subtract it from 2.6. And we go through all that and it gets real, real messy. So y'all, I'm going to show you a way on how we can find both the variance and the standard deviation without having to do all the calculations, okay? Because the calculations can get really, really messy. So y'all, I'm going to show you how we can find both the variance and the standard deviation. We'll do that for, let me see. We'll do that for a problem down over here. So we'll come back and I'll show you how to do it. We won't do it for our particular problem, but we'll do it in a second. Okay, so let's take a look here, y'all. We're going to make our probability distribution, okay? And then we're going to start finding some probabilities, just kind of like the way we did in the first problem. So what do we have here? Overtime hours. The number of overtime hours worked in a particular week for one employee, okay? Or per employee, I'm sorry. So there were 6 people that didn't work any overtime hours. There was 12 people that worked 1 overtime hour. 29 people who worked 2 overtime hours, 57 who worked 3, 42 who worked 4, 30 people who worked 5 hours overtime, and 16 people who worked 6 hours overtime. Y'all, first thing I want to do, I want to find the sum of our employees. Okay. So, y'all, first thing I'm going to do, I'm going to just take my calculator. I'm going to say, what's 6 plus 12 plus 29 plus 57 plus 42 plus 30 plus 16. Y'all, I'm coming up with a total of 192. Okay. All right. Now, the next thing we're going to do, y'all, we're going to figure out the probability of the number of hours that they worked. Okay. The way we're going to do this, y'all, we're going to use our calculator. And we're going to take, there were 6 people who didn't work any overtime hours. 6 out of how many, though? Anybody know? What's the number of employees that we had? Yeah. So we're going to take 6 divided by 192. Y'all, I'm going to go ahead and round this to 3 decimal places. I'm going to do every one to 3 decimal places. So y'all, with your help, what do you think? 0.031 or 0.032? 31. Okay, so right here, let's put 0.031. Okay, now we're going to do the next one. 12, y'all. 12 divided by 192 again. What do you think? 0.062 or 0.063? 0.063. So right here, 0.063. Okay. The next one, y'all. 29 out of the 192 again. What? 0.151? Okay. 0.151. Okay. The next one, y'all, let's see, 57 out of the 192. What do you think? 0.296 or 29.7? 7, good. 0.29. Okay, let's take the next one. 42 divided by 192. 0.219. Okay. Let's take 30 divided by 192. 0.156. And then let's take 16, y'all, and divide it by 192, 0.083. Okay. Now, let's just start going through the questions. Find the probability of a worker whose overtime is 1 or 2 hours. Y'all, what we're going to do, we're going to take the probability for 1 hour. We're going to take the probability for 2 hours. We're going to add those together. So 1 hour is 0.063. 2 hours is 0.151. My friends, I'm going to add those numbers together. 0.063 plus 0.151, 0.214. Y'all, once I get this table, the rest of the questions become real easy breezy cover girl for me to do. Okay. 2 hours or less. So y'all, 2 hours or less, we're going to look at the first 3 boxes, right? So probability of 0 plus probability of 1 plus a probability of 2. Okay. 0.031, 0.063, 0.151. And I'm coming up with 0.245. Okay. Part C all says between 3 and 6 hours inclusive. Okay. So let's figure out what that means. Between 3 and 6 hours, those folks right there, right? So let's add those guys together. Let's clear this out. 0.297 plus 0.219 plus 0.156 plus 0.083. And y'all, I'm coming up with 0.755. Okay. And then between 1 and 3 hours inclusive, y'all, I'm just going to look at these folks, right? 0.063, 0.151, and 0.297. Okay. And I'm coming up with 0.511. There we go. And at most 4 hours, sorry. And at most 4 hours, y'all, what do we say at most means? 4 or more or 4 or less? 4 or less. Okay, look, guys, if we're going to do 4 or less, y'all agree that these are the numbers we're really interested in? Okay, remember what we said? Before I do anything else, remember we said if we add up all these numbers here, all those probabilities, if we were to add them all up, y'all, that number should add up to the number 1. Okay, so we can add all these 4 right here, or the other thing we can do is we can say, look, let's find what those 2 add up to and then subtract it from the number 1, and that'll give me the same thing as those guys right there. So, y'all, I'm going to say what's 0.156 plus 0.083, and then I'm going to say 1 minus 0.239. And this is giving me 0.761. And we could add up the first 0, 1, 2, 3, and 4, or you can just do the other 2, subtract it from 1, and you get the same answer, right? Y'all, probability distributions can be pretty straightforward because once you make that table to find the answers, they're going to be pretty easy to do, right? The hardest part is making the table. I think the most tedious part was taking those numbers and dividing them by 192. The rest of it is pretty straightforward to do. Okay, so y'all, let me show you now, how do we find mean, variance, standard deviation from a probability distribution? Y'all, I'm going to do this using my calculator, okay? So I'm going to grab my calculator again. Okay, let me turn this guy on. Let me clear everything here. Y'all, I'm going to make 2 lists on my calculator, okay? So remember, how do I get to my list? I'm going to hit the stat button, and I'm going to go to number 1, y'all, to edit. Now, if you have stuff in your list, y'all, remember how you can clear it. You can go up to where it says L1, hit the little button that says clear, and then enter, and it should clear everything that was in your list if you had stuff in your list, okay? Now, y'all, what I'm going to do is I'm going to write these numbers as I go across. So I'm going to go 0 through 7. So 0, 1, 2, 3, 4, 5, 6, and one more, 7. Okay. Now, y'all, I'm going to do some stuff in my list too. So I think if I just hit my right arrow button, I should go to my list too. Guys, if there's stuff that's in your list too, go up, hit clear, hit enter, and your list 2 should be cleared. Now, y'all, I'm going to put those numbers in there. So 0.058, okay, 0.123, 0.165, 0.179. The hardest part, y'all, honestly, is just entering these numbers in. 0.212, 0.128, 0.084, and 0.051. Go down. Okay, now I want to get out of here, y'all. So I'm going to go second and quit. Okay. Then we're going to go to stat. And we're going to go to calculate, y'all. And we're going to calculate our 1 variable stats. Now, y'all, my calculator is a little bit older than I know a lot of you guys have. I'm going to show you how I'm going to do it in my calculator, and I'll show you how you do it on yours. On my calculator, y'all, I'm going to open up a set of parentheses. and I'm going to put my list one. The way I'm going to get to my list one from here, y'all, if I hit second and the number one, my L1 comes up. Then I'm going to hit the comma button, and I'm going to go second and the number two, and my list two is going to open up. Y'all, on your calculator, I think you should already have list one here, and then there's might be something that says frequency, and you want to make sure you have your list two on there, okay? But if you're using the calculator like this, y'all, or a calculator app, this is what you're going to enter in. We'll hit enter, and we're coming up with a couple of things. All right. So, y'all, it's asking us for our mean, our variance, and our standard deviation for the probability distribution. So, my mean, y'all, first thing I'm going to do here, I'm going to write X bar equals, let's see, what did I come up with? 3.339. 3.339. There we go. That's what it is. Okay. Now, my variance, y'all, my variance is going to be the little O squared. So if I come back here, I don't have the little O squared, but I do have the little O. So y'all, my little O would be like 1.83. And I think they're going to tell you to round to a certain number of decimal places. Okay. So now if I wanted to find my variance, y'all, I'm just going to take my calculator 1.83 and I'm going to square it. So I'm going to multiply it by itself. And again, y'all, like I'm going to tell you, they're probably going to tell you to round this to two decimal places. So I would write 3.35. Okay. Now, let's figure out what all of this stuff means. I'm going to read, what is this question even telling me? This question is telling me, look, we're looking at the number of school-related extracurricular activities per student. So what's the probability that a student is involved in no extracurricular activities? 0.058. What's the probability that they're involved in one extracurricular activity? 0.123, so on and so forth. Our mean, y'all, was 3.30 or 3.339. So right here, I'm going to put 3.339. So that means that the average student is involved, y'all, if it's 3 point something, that means that they're involved between 3 and 4. Right? Because you can't be involved in point something of a extracurricular activity. Standard deviation, y'all, is 1.83. Okay. So the number of activities per student is, let's see. Man, I'm trying to remember how they phrase this part here, y'all. I think it's going to say something like an average between 3 and 4 with a standard deviation, and they're going to round that, y'all, to 2. Okay. And again, I've copied this problem, y'all, directly out of the homework, just so, again, you could see how the way the problem is phrased. Okay. You're still going to put 3.39. What does that mean? The average is between 3 and 4, right? Standard deviation of 1.83. So that means that the student is involved between 3 and 4 extracurricular activities with a standard deviation of 2. Okay. Why 2? Because I'm rounding 1.83. Y'all, I got one more question similar to the one we just did. And again, y'all, I took this question directly from your homework. So again, we can kind of see how this is working here. Okay. So it shows, the histogram shows the distribution of hurricanes that have hit a country from 1851 to 2015, where 1 is the weakest level and 5 is the strongest level. So y'all, you remember like during the pandemic, do y'all remember that summer of 2020, we had hurricane, man, I can't remember what it was called, but y'all know what I'm talking about a few years ago, right? Hurricane went right over Edinburgh. I live in Edinburgh. I lost power, water, all that kind of nonsense, right? Okay, so y'all, hurricane category 1, the weakest. Hurricane 5, like Katrina back in the day, right? That's the most severe. So y'all, what we're going to do, we're going to make the same kind of thing. We're going to find mean, variance, standard deviation, the probability distribution. We're going to interpret the results. First thing I'm going to do, y'all, I'm going to take my calculator. Let me clear my screen. I'm going to go back to stat, and I'm going to go back to edit, and I'm going to clear my 2 lists. So y'all just go up, hit the button that says clear, hit enter. Go to list 1, go up, hit the button that says clear, hit enter. Okay, so my list 1, y'all, my list 1 is going to be 1 through 5. Those are the different categories of hurricanes we can have. We can either have hurricanes of categories 1, 2, 3, 4, and 5. Okay. Now I'm going to go to my list 2, and I'm going to enter in those probabilities. So 0.406, okay, 0.262, 0.213, 0.109, and 0.010. All right. Now, again, y'all, I'm going to quit this business here. I'm going to come back to stat. I'm going to go to calculate. I'm going to do my one variable stats. Y'all, like I said, my calculator is a little bit older. So I want to do list 1 first, comma, and then list 2. And again, if you're using the app, I want to say the apps work like this. I know in the other calculators, it'll be your list 1, and then your frequency will be your list 2. And then go ahead and hit enter. And so let's find our mean, variance, and standard deviation. So y'all, this is the mean. This is the variance. And this is the standard deviation. Okay. So let's come back here. My mean, 2.055. Y'all, when you're doing something like this, it's going to tell you do not round. Yes, sir. Yes, so do it like this. Let me quit here again. Let's see, quit. Boom. Let's clear it. So go hit stat, right? You're going to calculate your one variable stats. You're going to go parentheses. You're going to go second L1, and then you're going to hit the comma. The comma is right above the number 7. And you're going to hit second L2, close your parentheses, and hit enter. Got it? Awesome. You're welcome. You're welcome. No, it's all good. So y'all, remember, my variance is going to be the sigma squared, the little 0 squared. So look, y'all, I'm going to go 1.07. So let's go 1.07. Let's square that guy. Okay, and here, y'all, it's usually going to ask me to go to 2 decimal places, so I'll put 1.14. Oops, sorry. On the variance, they usually ask you to round to something. But on the mean, they don't. And then on my standard deviation, they usually ask me to go, I think it's 2 decimal places. So if I was going to go 2, y'all, I'd write 1.07. Okay. All right. Now, interpret the results. Select all that apply. Okay. So let's see. Let's go through each of these and figure out what's going on. So y'all, remember, the average is my mean, right? The average is my mean. My standard deviation is how much it can change by, okay? So y'all, look what it says here. The typical hurricane deviates, remember, that's my standard deviation, by about 2 category levels. Y'all, is that number about 2? 1.07, it's about 2? What do y'all think? 1 point, like guys, if I had $1.07, do I have about $2 or do I have about $1? Okay, so look, let's say, okay, you know what? We're just kidding, not A. We're not going to choose that one. Okay, let's take a look at the part B. The average hurricane is approximately a category 2. Y'all remember, the average is the same thing as a mean. Does that look reasonable? Does it seem reasonable to say the average hurricane is about a category 2? Yeah, it does. Let's put a check right there. Okay. Let's take a look at part C. The typical hurricane deviates from the mean by about 1 category. Look, y'all, remember, this is my standard deviation. My standard deviation, that's about 1. Doesn't it deviate by about 1 category level? Yes, it do. Okay. So far in B and C. Let's take a look at the 4th part. The average hurricane is about a category 1. No, it isn't. We said it's about a category 2. So we're going to choose B and C here. So y'all, let's just kind of get an idea. What is average? What is standard deviation? Okay, so we know hurricanes, right? We've lived through hurricanes. It says the average hurricane is about a hurricane of level 2, but some of them can be a 1 and some of them can be a what? If 2 is right here, guys, 1 to the left, wouldn't that be a 1? What would a 1 to the right be? a 3, right? So most hurricanes, y'all, are category 2, but some of them are going to be a 1, some are going to be a 3, right? Are there going to be a lot of 4s and 5s? Not too many. Most of them are 2s, but then the next 2 groups are either 1s or 3s. Does that make sense? That's really what standard deviation is kind of telling us there, okay, y'all? And I want to say, y'all, that is 4.1, okay? So, y'all, let me stop. Oh, no, did I not? I thought I hit record. Oh, yeah, I did. Okay,